So what they do is they know something about the geometry of how the seafloor lifts, and then they have the bathymetry of the entire Pacific Ocean basin, and then they do, so here it is, the things going, these dots are these buoys, and so they could kind of calibrate the initial model against the observations. And then this is a calculated sort of view of the tsunami going, and so you can see they talked about how it goes as fast as an airplane. So it takes, about, these are in hours, so it takes about 9 hours to get to the west coast of the U.S., and then it keeps going down. Most of the energy was directed more towards South America than western U.S., west coast of the U.S. But this is also, so you see the tsunami, the main front, but there's a lot of waves behind, so that's why they always talk about how, tsunami's not over when the first wave comes, because you could have some weird kind of back-directed wave, although usually the first one will be the largest. So this is 20, so the whole ocean's still going like 24 hours later with the shaking, or with the wave. So then there's some, this is, maybe you guys have seen this, but these are before and after things from, this is ABC, they did it. So the way this works is you have Sendai Airport, let me see. So what you can do is, you, hold on, escape. So this is this place, Sendai Airport, and this is the GeoEye, so this is the satellite that Google mostly paid for, but it's also something that's used for U.S. Intelligence. So it's a satellite, but it has a 60 or 40 centimeter ground resolution. So here's this airport, the Sendai Airport, and it's a regional capital. And then, so this is before, and then these sliders, the way this works is you grab this thing and you slide it, so here's after. And so you can see the tsunami swept across the place. It blew out this little village here. All this trash, just all this stuff is just totally destroyed. So that's that one. You can go down here. This is another small coastal town. You can see it's pretty much, they call this the Japanese heartland. It's pretty much agriculturally dominated region. And then, so this town just got totally blown away.
It sucks.
And then this is another one. So, comes in. So just really swept those buildings completely away.
Well, at least there's still some birds.
Jeez.
Mostly submerged fields.
It deposits a lot of sand and stuff on it too, right?
Right, so that's
So
important.
it's not gonna, it won't be air.
Remember when I talked about how they knew 869 is that here in the Sendai Plain, you see how on the runway this mud was deposited? Well, roughly the same amount of mud was deposited, and what they know is 869 because it's below a volcanic deposit that's like from the 840 or something. And they also know because written records in Japan are good, even 869, people were keeping track of things. So they knew there was a earthquake and tsunami, and it had this sort of similar characteristics in terms of how far inland the deposits went and how thick they were. So that's why they think that maybe a similar mega quake had happened in 869. So, okay, let's just keep going. What else do I have in here on the tsunami? Tsunami videos, actually I think I'll move on from them. So here's just the tsunami inundation as measured by Japan, like two days later. So you can see a lot of the tsunami inundation around Japan was modest, but there's many places with more than a meter. But that northern piece of Honshu, the big island, was more than 3 meters, and in some places it was significantly more. And one thing about tsunamis is part of the energy that comes from the tsunami, is from the seafloor lifting, but the other major part of the tsunami amplification and run-up is the geometry of the the shoreline, both in its bathymetry and in the shape of the coast. That's why tsunami means harbor wave, because so some of this amplification is not because the earthquake was different, it's because the coast was different and it was prone to amplification. So here's the Pacific Ocean observations. Most of the observations are from tide gauges. So you can see in places like in Hawaii, there were, maybe 2 meters, 1 to 2 meters, coastal U.S., Chile and Peru had a couple of meters in places. These dart buoys, the buoys are these deep ocean gauges. So they don't show much because they're in the open ocean. So the amplification it's pretty low in the open ocean. But whereas these are islands, basically every one of these yellow dots would be a tide gauge. Maui tsunami. So I have a couple minutes yet. So there was damage. People said that there's as much as 40 million in damage in the United States due to this earthquake because of tsunami damage.
What we're going to do is take us out, go around over Hualuku.
So this is just a quick thing.
And then from there we could go around.
People went in this is like a
West Maui, Lahaina, and around.
sightseeing flight over coastal Maui.
Back here, how's that sound? Sounds good.
This is wet.
Okay, here we go. All floated underneath there.
Maui Mayor Alan Arakawa, along with
See all
his
this
directors
water?
from Public Works, Wastewater Management, and the Department of Water Supply, went up in a
There's some mud
helicopter
that came
and
in.
fly on Friday morning to assess the impacts of 6-foot tsunami waves that flooded many
There.
inland
You
areas
see
and
that?
washed debris onshore on
So
Maui.
6-foot
The
tsunami
area
waves.
departments allowed directors
So
who were
it's-
all engineers to quickly evaluate which areas were in need of repair or cleanup, and allowed crews on the ground to begin work in restoring order to flooded and damaged areas. The tsunami waves generated by a large earthquake off of the northeast coast of Honshu, Japan Thursday.
So I don't want to keep going too much on that, but the point is that hit U.S. possessions. In California, the big damage was like in the Santa Cruz Harbor. Same thing, that San Lorenzo River, which comes to Santa Cruz Harbor, is kind of just a bad geometry to have amplification. The tsunami wave basically made the tide rise in the estuary, and I think most of the damage came when it went out, and it just sucked all these boats out, and it wasn't terrible, in terms of like just catastrophic, but lots of damage. So, okay, we're almost at the end. So here's how these things fit in. So this is the 20th century plus a little bit of earthquakes. So you could say, well, are we, what's going on? Has this ever happened before? And the answer is yeah, 1950s and 1960s it was worse. There were these big ones, 1956 in Kamchatka, 1960 Chile, 1964 Alaska, and these two were bigger even than what we've seen. But the population of the Earth was probably half as large as it is now back then. And so the other point to make about this is that here, as we go back, our ability to have complete records goes down. So, if we stretch this another 100 or more years, we don't really even have a great sense of what has happened. But especially in places that weren't very populated and weren't doing a good job recording. So places like Japan have pretty complete records, but the whole Pacific Basin is incomplete. But what we do know is we have had this series of big subduction events in the last 5 years. We don't think they're related, but we see, that they're happening. And, they're like basically Sumatra and Japan are similar in magnitude. I thought Sumatra was classified slightly larger. Chile's not that much smaller, but the damage from them was very different. So here then is this one. This is a plot from this guy named Roger Billum at University of Colorado. But here's magnitude versus fatalities. So in general, you can see there's a correlation. But what you guys remember from like the second or third lecture in this class is what happens with respect to fatalities in disasters in developed countries relative to not developed.
Well, not developed, you have more disease.
And just more death because of
Less
poor
response
infrastructure.
time. I mean,
There's poor infrastructure. I mean, the vulnerability increases.
That's right. So we tend to have higher fatalities in poor infrastructure or less developed countries, but the costs are lower as well. Sad to say, but so here is so these are actually quite a bit smaller earthquakes. Like Bam was actually a high 6 in Iran, and 35,000 people were killed. Here's Bhuj, which was an Indian earthquake. Hold on just a minute. China was about 90,000. Kashmir, Pakistan. So we see equivalent or greater death tolls in smaller earthquakes. And this one, if you do this is all 18,000, which is mostly tsunami related. You know, the direct earthquake deaths are probably down here quite a bit lower. Mm-hmm. And then Sumatra is includes the tsunamis around the Indian Ocean. And this doesn't have Haiti, which is 200,000. It's up here, but it's the size that it would plot over here is Haiti. So this just serves for context.
Is this just deaths caused directly by the earthquake, or is this including things like the destruction of infrastructure causes death over time?
This is pretty much the direct effects.
Including tsunami.
Including tsunami,
So
yeah.
the fatalities for each one could actually be higher.
Yes.
Because the earthquake in a way caused other deaths.
That's right. Now, nowadays, in the 20th century, probably following on epidemics are low, but prior events when sort of medicine wasn't as good, you could have significant
Well, even
additional.
within third world countries.
That's right, but even
And then if you go before modern medicine, populations were also lower and scattered, so the deaths were actually probably lower.
that's true.
The Haiti earthquake, I haven't seen any numbers on the cholera epidemic, deaths associated with that, but it must be less than 200,000.
Oh yeah,
They're
it's
keeping a handle on that.
yeah, but other just follow-on bad stuff is not part of these. Besides the tsunami. Okay, well, we probably better bring it to a close. That was my last slide. So, oh, no, it's not. Hold on. I got to show you guys this thing. We have a minute. This, because this is kind of a cool thing from, come on. So, when you bring it home to the U.S., let's just look at this. So this shows a comparison between Japan and Cascadia. So there's Japan on the left, Cascadia, which we mean is the subduction zone off of Washington and Oregon. Great earthquakes. We had this one March 11th, but we had one in January 26, 1700. And we know it because the Japanese called it the orphan tsunami because they had really good records and they always had an earthquake followed by a tsunami, but there was one pretty decent one that happened in Japan, and they were like, well, it didn't have an earthquake with it.
It was just a tsunami?
Yeah, so they were like, what happened? Well, then they traced it back to the coast of Cascadia, and so we know exactly when that earthquake occurred. And I'll just show you the last thing is then what that one looked like in terms of an animation. Because they kind of take what they think the geometry was for a magnitude 9. So you could put a 9 under Cascadia, and here's what it would look like. This is the mysterious tsunami. A mysterious tsunami recorded by samurai record keepers, flooded fields, washed away houses, killed people in Japan, arrived without warning. There it was. And here it is propagating, this is a model, right? But calculated tsunami effect, or tsunami, coming and hitting Japan, and also would have hit the rest of the Pacific Basin. And so this is there's a
Philippines and Indonesia pretty hard.
yeah. But at this time the Japanese samurais were pretty good record keepers, and so they had a good sense of it. So anyway, that's relevance to us even more. Okay, thank you very much.
Oh, yeah.
Do you paper Wednesday?